Okay, guys. Guys, we'll look up now. What are you typing in? Which question?
No, I just want to finish it.
How much time?
2 minutes.
2 minutes? Right, 2 minutes, and then we'll start. What you up to, Nikita?
I'm setting my calculator.
Yes.
What is the answer in the book is 3.49 and I get 3.5.
Oh. Did you get 3.5 or 3.51? Yeah, maybe it's a typo in the book. That's fine. I think a lot of people got 3.51. Yeah? Alright, we'll start now. Now, the next topic we're looking at is something called histograms. And these are not to be confused. Guys, are we all looking up now? Nikita? This is not to be confused with bar charts. So, for example, this is what a bar chart would look like. You'd have your data and you'd have your frequency. So maybe you have like 0, 1, 2, 3. Oh, okay, fine, 4. Right, and we'll make up some numbers. 7. Okay. So, here you have your F, and here you have your data, whatever it is, and this might be, maybe here is 0, 1, 2, 3, and 4, and then this goes up to 6, 8, 10, 6, which is the first one, and then 1 then. Okay, this is called a bar chart. And you notice some features about the bar chart. There's a gap between the bars. Yeah. And the height of the bar represents the frequency. Okay, that's a bar chart. So what I'm about to show you is a histogram, which looks similar, but there are important differences. So before I continue, you can write this down as an example of a bar chart. You want to note that there is a gap here. Oh, and I wrote these x values as single numbers, but you can have a bar chart that goes like 0 to 5, 6 to 10, whatever. They don't have to be single points. These could also be ranges as well. Yeah. Or, in fact, they don't even have to be numbers either for a bar chart. These could be grades, A, B, C, D, you know. Or it could be blood type or whatever. Yeah, so you actually have a lot of flexibility here on the X. A lot of flexibility. Can I scroll down? Yeah? Okay. Now, let's have a look at an actual histogram, see how that differs. So maybe this axis, I don't know, it could be measuring something in kilograms. Okay? And maybe here we'll just start off with 10, and we can go up to maybe 12 here, 14. I'll just put 3 bars here, and we'll say 1, 2, and then 3 here. Okay. Yeah, so in a histogram you don't draw a gap. Okay, and let me just put heights here. We'll say that this one is at 0.1. We'll make it easy. This one's at 0.2. There's 0.3, and this one is at 0.4. Okay.
Histogram, you didn't draw what?
A gap. Now, what is the difference? Well, the first thing is the height here could not possibly represent the frequency. Why not?
Because it combined 2 values.
No.
Percentage.
Why? Yeah, but why can't it not be the frequency? Oh no, come on now, guys. Put your thinking hats on. All right. Don't stress yourself too much. Why could the height not possibly represent a frequency? No. Yes. Yeah. Can you say I have 0.2 of a student? No.
Can I have
Yeah. Oh, frequency means count, and we count with whole numbers. 1, 2, 3. Yeah. All right. Our brains are engaged now?
Yes.
Yeah. Okay, good. Right. So, as I was saying, the heights could not possibly represent the frequency. Now, each of these bars have a width. I kept it simple and gave them the same width here. 2 here, okay? 2 and 2 and 2. Okay. Now, actually, I need to change these numbers a little bit just to make them a bit more believable. They're a bit too small right now. I'll make them. Let's see. I'll make this one 0.5. Okay, and this one now I'll make 1.0. This one here I'll make 1.5, and this one here I'll make 2.0. So again, it can't be frequency because the last one is 0.5. Okay. Now, let's calculate the area of each bar. So what's the area of this first bar? 2 units. And the area of the second bar? 4 units. And then the area of the last bar? 1 unit. 2 times 0.5. Now, in the histogram here, put your feet down, okay? Now, are you listening?
Yeah.
So the base is 2 and the height is 1, so the area is 2. 2 times 2, 4, and 2 times 0.5, 1. Okay. Now you notice something about all of these areas are actually whole numbers. In fact, that's the key thing about the histogram, is that the area of the bars is equal to the frequency, or the height in the previous chart. So the area represents the frequency. Okay, so if we think about it, we can figure out maybe what we can call the y-axis. Okay, so you'll really have to think about the units here for a moment. If I draw a little rectangle here, it'll help you. Okay, so what units were we using on the x-axis in this example? Kilograms. Okay, and the area here is frequency. Yeah, and the height here, for the moment, I'll just call it h. So you have kilograms times the height is equal to frequency. So what unit should the height be? It's like a density, isn't it? Yeah. It's like a frequency per kg. So it's a little bit like a density. And the units here would be frequency per kilogram. Technically is the unit. It's how many of the thing you have per kilogram. Now, before you write that down, it is possible to still have a histogram and to have the height representing the frequency. I just need to make a small little change here. What would I change to the histogram so that now the height also represents the frequency? And it has something to do with a small change on the x-axis.
Remove the gaps?
Yeah. We nearly have it. What would I do? Something to do with the gaps or the lengths.
Separate them.
Not separate them. Change the class width to what?
Points.
No. Think about this. If you were to make all the bars have a width of 1, then the formula for the area, remember, is base times height. But if the base is equal to 1 unit, then what's the area equal to here?
1.
The height.
Yeah.
Yeah. So as long as you keep all the widths of 1 unit, then both the area and the height represents the frequency in that situation. So like here, I need to have 2. So maybe, I'll just put 1, 2, 3, 4. Maybe if you group them in units of 1 kilogram, maybe you discover you had one that was between 10 and 11, and one that was between 11 and 12. Now, how many do I have here in total? 2. And what's the area? 2, isn't it? 2 times 1. Now, between 12 and 14, how many was I supposed to have? 4. So maybe, for example, it was I had 3, and then maybe I had another 1. And the last one is 1. Now, that last guy, maybe there was nothing that was between 14 and 15, and then you had one that was between 15 and 16. Now, do you recall last week I said your choice of widths can change the shape here? Between the two graphs, can you see that we now are looking at different shapes? And we haven't changed the data. We've just changed the class widths. We've grouped the data differently, and now we have different shapes. Okay? But what is nice about this histogram is that the heights and the areas are the same. The area of this bar, 1. And this bar, 1, 3, 1, and 1. And the heights are also 1, 1, 3, 1, and 1. And these two are actually the same data. Okay? Which should we use? Well, in this situation, I think it's actually fine to use this one. But not always. We wouldn't want to use this if we start having too many bars. Whereas we'd want to use bigger class widths if we're going to have a large range of data. Okay? Now, I'll let you draw this, and then we'll look at what is the application of the histogram. So what is useful, what can we do with the histogram? Yep.
How did you change the y-axis to 1, 2, 3, 4?
Oh, I need to pick units appropriate. So, guys, if you want, you can think about it as a formula. The height is equal to the frequency divided by the class width.
To get the height.
To get the heights. So if I use this formula, I discovered that the biggest height I get is 3 when I looked at the middle data. And do you know what I'll do? I'll write the data down as well. I'll say it's... it could be given in a table. In this example, I'll pretend I gave you the data. So you have 10.5 kilograms. We'll say that I gave you 11.5 kilograms, 12.5 kilograms, 13.5 kilograms, and then we'll say the last one was 15.5 kilograms. So there's only 5 data points. not realistic. You wouldn't draw something for 5 data points, but you can see both histograms are consistent with this data. Yeah. How many are between 10 and 12? Well, apparently 2. And there are. So write everything down here, please. So I need to scroll down to another example. You got that? Can I scroll down?
Yeah.
Yep. So you were asking me, would the frequency be given? So here's an example that's quite clear where the frequency is given. So we'll have our data, and usually in the exam they give it vertically like this. So for example, this could be, let's say, heights in centimeters, and this would be frequency. So I'll say, I don't know, we'll say 0 to 9 centimeters. No, I'll keep it 10 units, tens. And then I'll say 10 to then 15. Now you notice straight away the bars don't have to be the same width. 15 we'll say to 20. 20 we'll say to 25, and then 25 we'll say up to 35. Okay, and we'll say 1, 3, 5, 3, 1 as the frequencies. Okay, you don't have to decide on what class width to use. It's already provided here. So the first bar should start where? 0 and finish where? 10. And the second bar begins at 10 and finishes at 15. So, in the exam, what you would need to... Now, guys, focus. In the exam, typically the first question would be, extend your table so that you can draw the histogram. So what rough work calculations would you need to add here? Yeah, well, I think the first thing you should do, which would be nice, is to write in the widths. Okay? And then to write in the densities using the formula frequency over width. So I'll do the first one. What's the width? 10. And what's the height here? The height would be the frequency, which is 10, over the width, which is 1. So that is 10. Oh, sorry, I wrote upside down. Sorry. 1 over 10, which is 0.1. Right, the next one, what's the width? 5. So frequency over width, 3 over 5, 0.6.
From where did you get the 5?
10 to 15 is 5 units.
Okay.
Yeah.
Okay.
Right. I'll let you finish and draw.
Okay.
Let's see what you get. Okay, so you should have the table finished there, the extra pieces of information here. And let's try and draw this now. Height in centimeters, and this is this is density in per centimeters. Okay. And I'm starting here, I'll skip a little bit and I'll start here at 10, and then I'll have 15, 20, 25, 30, 35. And how big do I need to go on my y-axis? What's the largest value? No? Try again? 1. That's 1. And there is 0.5, 0.25, 0.75. Okay, so the first one, what is my height? 0.1, isn't it? And then my next one is 0.6. 10 to 15. Oh no, sorry, I'm so sorry. I do actually have to start at 0, don't I? Yeah, so no skipping here. So there's 0. Okay, so the first one is 0.1, and then the next one is 0.6, and then the next one is 1 up until 20, and then the next one is 0.6 up until 25, and then the last one again is 0.1. Then we go. That's what the histogram looks like. Now, what is the application of the histogram? Why is it useful? Well, let's pretend I didn't have the histogram for a moment. So suppose I have the table like this. How many samples are between 10 and 15 centimeters?
10.
5.
No, 10 and 55.
Now, just think before you open your mouth. I'll say it again. No, look. How many samples are between 10 and 15?
3.
3. Okay?
So the width is different, right?
Yeah. Oh, yeah. How many samples between 15 and 20? There's 5 samples between 15 and 20 centimeters. Now, suppose I asked you something like, how many samples are between 12 and 20? Does that table provide that information?
No.
Not directly.
More than 5.
More than 5, correct, yes. And less than 8.
Yeah.
Right? So, what you can do with the histogram is, because you know the area represents the frequency, you can just mark off 12 here. Yes? What did I say? Between 12 and 20, wasn't it? And
Yeah.
mark off 20 here, and then calculate this area. Okay, so let's calculate this. How many shapes are we looking at here?
1.
Yeah, 1, and then we can split it up into 2 parts. So let's do the part on the right. What's the part on the right? What's the base? How many? 5. And the height? 1, so that's 5. And then let's look at the piece on the left. What's the base? 3, because remember we said we started at 12. Yeah, 12 is 3, and what's the height? 0.6.
Yeah.
So 0.6 times 3, 1.8. So now it's only an estimate. So we estimate between 12 and, what do we say, 20, the frequency will be roughly 6.8. Yeah, it was 0.6. You can see it there.
And with how do we know width and height?
What do you mean?
How do you find the right numbers? The
Width?
height? Yeah. And
Well, between 10 and 15 is 5. Between 15 and 20 is 5.
and
So do you not do subtraction in Ukraine?
remember.
Long time ago. Picture you're 6 or 7 years old, maybe. Right. Yes, just 20 minus 15. That's all. Subtraction. Okay. What? You have a question about subtraction as well? What?
I'll just scroll down a bit.
Yeah.
For the box, you drew it from 12 to 15.
Yeah.
So it's from, what's the B from like the middle, or they can give you a value?
Oh no, it could be from anything to anything. Yeah. I just picked 12 to 20.
Okay.
Yeah. Okay, so look, frequency, our estimate is 6.8, but of course, you might say, well, we can't really have 6.8.
Did you add or
For which?
5 for the frequency.
Which? Oh, 6.8. Well, what do you think? 5 and 1.8. Is it likely that I added them or subtracted them? Added them, likely, isn't it? Yeah. So you might object saying, well, frequency can't be 6.8. Okay, so look, it's fine to say our estimate is 6.8, but then if someone said, well, give me a prediction, well, you might say I can't really predict 6.8 because I know full well that I'll never get 6.8. So if you had to give a prediction, yeah, you would say, you'd predict that maybe it's 7. Yeah, but which is more likely? 7 would be more likely. So this is a useful application of histograms here, is calculating frequencies. Okay. All right, add that one now. That would be a typical exam question. Oh, yeah. And then a follow-up part would also be, a follow-up exam question part would be something like, what is the modal class? So modal is the adjective for mode, and mode means most frequent. So what would be the modal class here? 15 to 20 would be the modal class. Okay.
Mode is like the repeated number, right?
Yeah, most common.
But it should be one number, not two values.
No, because I said carefully, if you heard my question, I said, what is the modal class? Not as what is the modal height. So if I said, what is the modal height, actually, what would you say is the modal height here?
5.
No. Estimate the modal height. What is it?
5. Because frequency is the height.
Okay. You're mixing up height and height of the bar. Right, okay. Imagine, yes, that's it. What is the modal class? The most common class was the 15 to 20, right? The most number of samples was in this class. We had 5 samples between a height of 15 and 20 centimeters. Okay? So if you were to estimate it, you would say 17.5 was the most common height. Yeah. Yeah, I'm imagining there are 5 samples of height 17.5 in this group. Now, are there really? No, it's just our estimate. Yeah. Now, let's do another estimate. What's the median? Well, how much data do we have here? 5, 6, 7, 8, 9, 10, 11, 12, 13, is it? 13? So, it's going to be exactly the same. The middle number will be in this one here. Actually, we could have seen that because of the symmetry as well. So, it's also 17.5. And finally, suppose someone asked you to calculate the mean. Well, you would have to do a little bit of estimating here. You would have to replace this one by midpoint, correct. So 5, and then what would be next? 12.5. And how many of them would you have? Yeah, and the next one would be 17.5, and how many would you have? 5 of them, etc. And then you could get the mean. But I wouldn't be surprised if the mean worked out to be 17.5 again in this one here. Because of how symmetric the data is. Yeah? Yes?
So the frequency from the chart, is it the same, the other one, when you divide the frequency by the width?
Oh yeah. The height here, the bars,
Yeah.
is the frequencies divided by the widths.
So, is it okay, like, if we just put the frequency without dividing?
That's actually the next thing I was about to say. So, if I made one change here, if I kept all these numbers the same, 10, 15, 20, 25, 30, 35, but instead of putting the density here, I put the frequency, 13531, would I have a histogram anymore? No, what would I have? A bar chart. Yeah. For a histogram, the area represents the frequency. In special situations, we can make the height also represent the frequency. But what is that special situation? When the widths are 1. No, not the same. Well, they all have to be the same. They all have to be 1. Okay. If the widths are not 1 and the height is the frequency, the height of the bar is the frequency, do we have a histogram? No. Okay. Now, I need to tell you something. It might have happened already, or if not, in a few weeks, this guy wearing a shirt and a sweater teaches you biology. He'll come in one day and he'll say to you, for a histogram.
Oh, okay.
Well, has he done this already? No, okay. He'll say, oh, for a histogram, the heights are just the frequencies. Now, when he does that, okay, you tell him he's a dirty liar, and that's not true, okay? In the biology exam, they don't care about this. In the biology exam, they allow the students to plot the frequencies as the heights, with no regard for the x-axis and the area.
There's no regards to the width, yeah?
With no regard to the width.
Because the width is the actual variable.
Yeah, so like in biology, when they plot this, what they'll do is they'll keep it the same, like 10 to 15, but they'll make a height here of 1. Which, of course, for us is wrong, because what's the area now? 5. And were there 5? No, there's 1. Okay? So, when you see that happen in biology, I don't want you thinking, oh, there's 2 ways to do this, or this is a better way, I'm doing it this way. What you must understand is that is the wrong way, and is only allowable because whoever writes the biology exam doesn't know the difference between a histogram and a bar chart. That's the only reason it's allowed. Okay? Huh? Oh yeah, well, that's funny then, because it means that yeah, but I mean the safest thing to do is just to do it properly. Okay? I mean, you're free to take the shortcut if you're willing to bet that the person who's writing the exam this year has been for the last 5 years, or 10 years even, the same person who has gotten it confused between the two. But look, the simplest thing to do is just do it properly. And properly means you have to calculate the heights. Yeah, it's not a big deal.
Prediction of frequency is 7.
Yeah. Okay, let's see. Oh yeah, last type of histogram, just to show you. Yeah, this last type. Can I scroll down?
Yeah.
There's a special type of histogram called it has 2 names. It can be called the Normalized Histogram, or it can sometimes be called the Relative Histogram. It means the same thing. And there's not a big difference here. The only thing you do is you take your data, and instead of working with the frequency, you work instead with the relative frequency. Do you remember the relative frequency? Also called P, the proportion. So for example, how much did we have here? 13, wasn't it?
Yeah.
4, 8, yeah, 13. So what you do is you replace your F with a P, and all these numbers you divide by 13. So the first one would be 1 over 13, and then 3 over 13, etc. And then after that, everything is the same. So what are the widths? Well, what was the first width? It's still 10. And the next one is still 5, etc. But now, the heights are different. So the first height would be 1/13 divided by 10, which would be quite a small number. What's that? 0.007. Fine, yeah, it's very small. Very small. Now, I won't go through the whole process again, But I wonder if somebody can tell me what would be significantly different. Well, firstly, all the heights would be much smaller, wouldn't they? So we'd have to use a smaller scale. Perhaps we'd only go as high as 0.1 this time. Okay. The area will be smaller. If I calculate the area for the first one, I'll get whatever 1 over 13 is. Yeah? Now, let's remind ourselves, what did the 1 over 13 mean? Yeah, the area, but it's not the frequency anymore. What did we say it represents? Proportion, which is another word for probability or percentage. Okay? So what you're doing in this diagram is you're making all the areas represent probabilities. So what is 1 over 13? 0.08 or something?
Yeah.
Okay, so roughly 0.08.
Yeah.
So this bar has an area of 0.08, which is 8%. So you're saying that 8% of the data is between 10 and 15. Okay? And then you realize you know something about the total area. If you were to add the area of all the blocks up, you get 100%. Yeah? Because it should be one whole unit.
Yeah, what I was saying.
Yeah. In fact, if you were to draw this, you would get exactly the same shape as before. The only thing that's different is what? The y-axis values. They'd be scaled down. And they'd be scaled down so that the areas now represent probabilities. In fact, you know how many times smaller this scale will be. 13 times smaller. Because what have we done to all the frequencies? We've divided them all by 13. So 13 is the total. So all the numbers here will be 13 times smaller. You're scaling down by a factor of 13. Now, I don't think they'll do this in the exam. I've never seen them ask you to draw a relative histogram. Okay? But you know, when I look at the syllabus and it says learning outcome, students need to draw a histogram. Well, I just want to cover the possibility that someone might say, okay, give me a normalized histogram. This is a normalized histogram, a relative histogram. Now, like I said, there's 12 years of exams, and I don't think they've asked it, or if they have asked it, it has only been once, maybe the year that I wrote the paper. So, it's highly, highly unlikely that they'll ask you to do a normalized one. It will be more like the original one I did there. Okay. Right, so there's only 5 questions here. But you can skip the first one if you like, so you can just start with number 2.
Where did you get E?
Where did I get what?
E?
No.
007.
E007.
Yeah.
E007. What? Where?
Under. Near to the bit.
Here?
No, over. Yeah.
This?
Yeah. No.
This? This?
Where's the mouse?
Oh, this?
Yes.
You have a laser pointer, do you? Here, this?
Yeah.
Okay, well, firstly, that's not E. What letter is that? Yeah, but what letter is it?
E.
Rho, Greek letter. That was P divided by W.
And
Gives us 0.007, I guess.
we're using it for.
For the height. Yes. Okay, I'm going to close this now. No?
I have a question.
Yes.
From where did you get the 1.8 when you
1.8.
the estimate is between 12 and 20?
0.8.
Yeah.
Oh, that's the area of the little rectangle on the left.
How did you calculate?
Oh. This distance was 3, and this height was 1.8. So, sorry, what was the height? The height was 0.6, sorry.
Okay.
So it was 3 times 0.6. which is 1.8. Off the phone now, come on. Get working.